In this video, we're going to look at the first derivative test. We use the first derivative test to analyze a function and find where the function is increasing, where it's decreasing, and where it has relative minimum, relative maximum, and saddle points. So here at the top I have the general rule, or how we're going to use the first derivative test to tell that stuff. If f prime of x, or the derivative of the function, is equal to 0, then f of x has a relative min, relative max, or a saddle point. And if f prime of x is greater than 0, then f of x is increasing, so the function is then increasing. And if f prime of x is less than 0, then f of x is decreasing. And the steps to use the first derivative are, we're going to take the first derivative, and then we're going to set the derivative equal to 0 and solve for x to find the critical values. Now the critical values end up being your relative minimums, your relative maximums, and your saddle points. And then we're going to make a sign chart to find intervals of increasing and decreasing. So let's take a look at an example. So here I have find the relative extrema, which are our relative minimums and our relative maximums, and the intervals where the function is increasing and decreasing. So we're going to use the first derivative test to do that. So step 1, find the derivative. So we have f prime of x is equal to 9x squared minus 9. Step 2, we're going to set the derivative equal to 0. So we have 9x squared minus 9 is equal to 0. And then going to add 9 to both sides. Divide both sides by 9, so we have x squared is equal to 1. And then x is equal to plus and minus 1. So now our critical values are plus and minus 1. For part 3, we're going to make a sign chart, and we're going to draw a straight line and put our critical values on it. -1 and 1. And now we want to use test points. So we're going to test points in all of these intervals. So here I'm going to test f of -2, f prime of -2, f prime of 0, and f prime of 2. And remember, we're doing this to find out if we have a positive number or a negative number, because if it's positive, our function is increasing. And then I'm going to write our derivative over here closer. So f prime of x is equal to 9x squared minus 9. And I'm going to say that this is equal to 9 times x squared minus 1 to make our calculations a little easier. So f prime of -2, -2 squared is 4, minus 1 is 3, times 9, so we have 27 here. So if this number is positive, that means our function is increasing in this interval. And f prime is 0, 0 minus 1, so is -9 total. So because it's negative, it's less than 0, we're decreasing. And when we put 2 in, we get 27 again. So we're increasing again. And now we need to look at these two critical values and see if we have relative mins or relative maxes. So here we're increasing and then we're decreasing. So if we're going up on this side and then back down on this side, that means we have a max. So we have a relative max at -1. Max. And here we're decreasing and then we're increasing, so we have a min. And now let's tie all the information together. So we have a relative maximum at -1, and then we need to take and find the other point. So we want to find f of -1. And our function we started with was 3x cubed minus 9x. So we have f of x is equal to 3x cubed minus 9x. So if we put -1 into this, Negative 1 cubed is negative 1, so we have negative 3 plus 9 is 6. So we have a relative max at negative 1 and 6. We have a relative min at 1. And then when we put 1 in here, f of 1, we get 3 minus 9 gives us negative 6. And then we're increasing. On the intervals of negative infinity to negative 1 and or union from 1 to infinity. And we're decreasing from negative 1 to 1. In this next example, we have a rational function. So we have f of x is equal to x squared divided by x minus 3. So the first thing we need to do, and we didn't do this in the other one, it was a polynomial, is identify the domain. So here I want to identify the domain. So the domain of this function is everywhere except for where the denominator is 0. In this case, that's 3. So we have negative infinity to 3 and 3 to infinity. Now this is important because when we're answering a question about increasing and decreasing or relative maximums and minimums, we can't have 3 being any of those points because the function doesn't exist there. So now the steps are the same as the last problem. So step 1, take the derivative. So f prime of x is equal to, now we have the quotient rule, so the denominator times the derivative of the numerator, which is 2x, minus the numerator, x squared, times the derivative of the denominator, which is just 1, all divided by denominator squared. So now, here I'm going to simplify this. So I get 2x squared minus 6x minus x squared divided by x minus 3 squared. And now we have 2x squared minus x squared, so we have x squared minus 6x divided by x minus 3 squared. And now we need to take that and set it equal to 0. So we have 2, and we have x squared minus 6x all divided by x minus 3 squared is equal to 0. And remember, we can just set the numerator equal to 0. And why that works is because if we cross multiply, we would have x squared minus 6x, which is x squared minus 6x, is equal to 0 times x minus 3 squared. So it turns out where the denominator goes away. So now we solve this. So I'm going to factor out an x and have x minus 6 on the left side is equal to 0. So we can see that this is equal to 0 when x is equal to 0 and when x is equal to 6. And now part 3, doing our sign chart. An important difference in this problem that we didn't have in the last problem is we didn't have a discontinuity in the last problem. And you need to make sure to include your discontinuity in your sign chart, as the signs could change at the discontinuity. So we have 0, one of our critical values, 3 is our discontinuity, and 6 is our other critical value. And now we're going to evaluate the derivative again at points in each of these intervals. So I want to look at f prime of negative 1, f prime of 1, f prime of 4, and f prime of 7. And I'm going to rewrite our derivative here too. So we have f prime of x is equal to x times x minus 6 all divided by x minus 3 squared. So at -1 we have 7/16. So that means that we're increasing in this interval. At 1 we have -5/4. Means we're decreasing. And at 4 we have -8. Again, decreasing. And at 7 we have 7/16. So we're back increasing. And now we need to evaluate each of our critical values. So at 0 we're increasing and then decreasing. So we're at a max. Remember, this was a discontinuity. And then here we're decreasing and then we're increasing. So we're at a min. And now we need to tie everything together like we did on the last problem. So our original function was x squared over x minus 3, because we're going to need to evaluate some points. And now we can say we had a relative max at 0. And when we plug 0 into our function, we get 0. So I could put here f of 0 is equal to 0. We have a relative minimum at 6. And when we put 6 into our function, we get 36 divided by 3, or 12. So 6/12 is a relative minimum. And then our function is increasing from -infinity to 0, union 6 to infinity. And here we're decreasing from 0 to 3, union 3 to 6. Remember, a function is discontinuous here, and this is why it was important to write down the domain so that we remembered to separate this and have a union and have two different decreasing pieces as opposed to the decreasing from 0 to 6. And that's all for first derivative test.